This lesson is 10.4, Inscribed Angles and Polygons. So an inscribed angle is an angle with its vertex on the circle, and the two sides are chords. So in our picture here, point B is on the edge of the circle, and the chords AB and CB are the sides, so angle ABC would be an inscribed angle. The intercepted arc is the arc that lies between the endpoints of an inscribed angle. So if these are the endpoints of our arc, right here, I like to think of it as we're shining a flashlight at point B, and it's lighting up on the circle between A and C. So that's the intercepted arc. So whenever we have an angle that's vertex is on the circle, we're going to use an on formula. And it's twice the measure of the inscribed angle is equal to the measure of the intercepted arc. So 2 times the angle equals the arc. And this is going to be the formula that we use anytime we have an angle on the circle. So for example 1, we want to find the measure of angle WXY. So we're looking for this angle over here. So I'm going to set 2 times angle equals arc. So 2 times x, we don't know it, equals the arc, which was 62. And we're just going to solve this. Divide by 2 on both sides, we get 31. So the measure of angle WXY is 31 degrees. Here's a check-in for you to try. You can pause. Answers are posted on Google Classroom. For example 2, we want to find the measure of arc DGF. So we're starting at D to G all the way to F. So right now that's my variable. And the angle that opens up to that arc is 113. So 2 times angle equals arc. 2 times the angle in this case now is 113 equals the arc. I'm just calling X for right now. So 2 times 113 is 226. So the measure of arc DGF is 226 degrees. Here's a check-in for you to try. You can pause. Answers are posted on Google Classroom. For example 3, we want to find the measure of arc RS and the measure of angle STR. So let's start with arc RS. Arc RS is here. And if I pull back from this arc and I look for an angle that was inscribed, we could say this angle here that was 31 degrees is an inscribed angle for this intercepted arc. So 2 times angle equals arc. 2 times 31 is equal to the arc. So the measure of arc RS is 62 degrees. And I now know that this arc is 62 degrees, and they're looking for angle T. If I take the 2 sides of angle T, its intercepted arc is that same 62. So the 31 that was here could also go here, because if I do 2 times angle equals arc, it's now 2 times angle T equals the arc, which was 62, and we get 31. So the measure of angle STR is 31 degrees. And we'll actually come up to a property, a theorem or something that tells us that we can do that part there. But for right now, there's a check-in here, finding the measure of angle T and the measure of arc QR. This is tricky. They're not asking for arc QT, they're asking for arc QR. So you can find QT first, and then since TR is a diameter, use the fact that these two should be a semicircle. You can pause. Answers are posted on Google Classroom. So here's what I was talking about with our overlapping arcs. If 2 inscribed angles intersect the same arc, then the angles are congruent. So if 2 different flashlights shine their light on the same spot, those flashlights are the same. So here angle B opened up to arc AD, and angle C opened up to arc AD, so angle B and angle C would have to be the same. So in example 4, we want to find the measures of both arc RST, so this one here, and angle RUT, so this one here. And since these 2 angles share the same arc, they will be congruent. So as soon as I know one, I know both. The problem is the arc that they're using is RT, and I don't currently know how long that is. So we can find that by adding up the three angles and arcs we have, the three arcs we have. So 64, 75, and 139 together equal 278. And if I take that away from 360, 82 degrees was left over for that angle. So now we can do 2 times angle equals arc. So 2 times, like S, is equal to the arc, which was 82. Divide by 2, we get 41. So the measure of angle RST is 41 degrees. And since they're congruent, the measure of angle RUT is 41 degrees. Here's a check-in for you to try. You can pause, answers are posted on Google Classroom. For example 5, we want to solve for x. So now we're just incorporating algebra into the problems. This is still an angle that's on the edge of the circle. We know the angle is 8x minus 9. My arc is 158. So 2 times angle equals arc. 2 times my angle was 8x minus 9 equals my arc was 158. We'll distribute here. So that's 16x minus 18 equals 158. We're going to add 18 to both sides. So 16x is equal to 176. And when we divide by 16, we get x equals 11. Here's a check-in for you to try. You can pause. Answers are posted on Google Classroom. For check-in 6, it's the same idea. It's on, but there's no variable here. And I don't have numbers here to just add them all up to 360 right now. So what I will start with is I will use my angle to find my arc, using 2 times angle equals arc. 2 times 67 is equal to the arc. And we get 134 is that arc. Now the exterior should add to 360. So we could do 134 plus 120 plus 5x plus 21 equals 360. So if we combine our like terms, 134, 120, and 21 are 275. If we take that away from our 360, we get 85. And dividing that by 5, x is 17. There's a check-in here for you to try. This is a little bit different. When you solve for the arc on this one, it will still have a variable in it, and that's okay. Or you can find out what this arc should have been first and then just set it up. That's probably the better way to go. You can pause. Answers are posted on Google Classroom. So the last things we'll talk about in this section, if an inscribed angle intercepts a diameter, then that angle is a right angle. Another way to think of it is if you have a triangle inscribed in the circle and one of the sides is the diameter, then it's a right triangle. And for quadrilaterals, if a quadrilateral is inscribed in a circle, then the opposite angles will be supplementary. So they will not be equal to each other like we did in most of the quadrilaterals we worked with. Instead, the ones across from each other will add up to 180. So for example, 7a, we see that we have a triangle inside. This side is the diameter, which makes it a right triangle. So x is equal to 90. And then x plus y plus 40, or 90 plus y plus 40, would have to add to 180 because all triangles are 180. So y plus 130 is 180, and y would be 50. Example 7b, we have a quadrilateral. So the opposite angles, the ones across from each other, will have to get added up and set equal to 180. So c plus 2c minus 6 would be 180, So 3c minus 6 is 180. Add our 6. 3c equals 186. And divide by 3. C is 62. And then 10x and 8x are opposite each other. So 10x plus 8x is equal to 180. So 18x equals 180. And x would equal 10. There's 2 check-ins here for you. You can pause. Answers posted on Google Classroom. For our final example, we see a triangle that's inscribed in the circle. The diameter is one of the sides, making it a right triangle. So this angle over here, since they had to add to 180, would be 47 degrees. What I can now use is this angle over here is on, and it's this intercepted angle, arc. So 2 times angle equals arc. 2 times the 47-degree angle is equal to the 9x minus 14 arc. So this is 94 equals 9x minus 14. Add our 14. 108 is equal to 9x. And when I divide by 9, x is equal to 12. So the final problem is here. You're looking for arc FE. Answers are posted on Google Classroom. And that is the end of section 10.4.